precisely because it has the materials needed to support life, it also has the materials needed to support civilization in a way, for instance, that the moon does not. And if we can go to Mars and learn how to turn those materials into resources, then we can settle Mars.
Why Mars? Like, what makes Mars the mother lode of human expansion?
Well, okay, first of all, in the short term, Mars is where the science is, and it's where the challenge is. Okay, I mean, Mars is the Rosetta Stone for letting us know the truth about the potential prevalence and diversity of life in the universe, because the early Mars was similar to the early Earth in essentials. And if life could evolve in that environment on Earth, and if those steps were high probability, then they should equally have occurred on Mars, although maybe not in precisely the same way, which means that you could have very diverse types of life on Mars. In other words, not necessarily using DNA and RNA, for example, for the information system, but some other genetic alphabet, just like everybody needs an alphabet, but there's quite a variety of alphabets on Earth that all serve the same function. But in the longer run, precisely because it has the materials needed to support life, it also has the materials needed to support civilization in a way, for instance, that the moon does not. And if we can go to Mars and learn how to turn those materials into resources, then we can settle Mars. We can make Mars habitable for us. In other words, an environment is habitable for you when the materials that are there are resources for you. Okay, and this is a function of your technology. I mean, also the materials have to be there. But, if you're stranded in the mountains and there's a lake, are the fish in the lake a resource for you? Well, if you know how to create fishing gear and fish, then they are. If they're not, if you don't have that skill, then they're not. Of course, if they're not there, they're not either. But both of those things are required. Now, on Mars, the materials are there. And if we develop the ingenuity, then all of a sudden it's a resource-rich environment, just like that mountain lake filled with fish is a resource-rich environment for the person who's stranded there, provided they bring the right technology to the problem. And this is the case with Mars. But if there's no lake, and there's no lake on the moon, as it were, that is, there's some water in permanently shadowed craters near the lunar South Pole, but on Mars you've got continent-sized regions that are 60% water by weight in the soil. You have massive glaciers bigger than the American Great Lakes, as far south as 38 degrees north, which is the latitude of San Francisco. So Mars has got water in a serious way. Mars has got carbon. It's carbon dioxide dominated atmosphere. We are carbon-based life forms. Everything we are and everything we eat is made of carbon. A lot of the materials, carbon, whether it's natural fabric or artificial fabric, it's carbon. And even things that aren't carbon are made with carbon, like steel, aluminum. Frankly, there's carbon involved in all these processes, and there's no carbon on the moon. Lots of carbon on Mars, everywhere on Mars. There's nitrogen on Mars, no nitrogen on the moon. These are the elements of life. Okay, and then we get into the elements of industry, and the moon only has about half of them, and Mars has got all of them. And Mars has had a complex geological history, which is necessary for creating mineral ore. Since the earliest civilizations, people have used copper. Even Copper Age, Bronze Age were the first two ages of metal use on Earth. Well, guess what? Copper is only 60 parts per million in the Earth's crust. So how were ancient Egyptians able to use it? Well, because there's natural processes that concentrate it into either very concentrated copper sulfates, things like that, or even metallic copper. Some American Indians actually used natural metallic copper formed by nature. Well, the moon's all trash rock. On moon, if there's 60 parts per million on the moon, it's just scattered around like it's 60 parts per million. It's not brought together by anything. But Mars has had volcanic processes and the water hydrologic processes and hydrothermal processes and possibly even biological processes that have been involved in concentrating mineral ores on Earth. So it's likely to be mineral ore on Mars and not on the moon. So you got ore, you've got the elements. You also have a 24-hour day as opposed to 2 weeks of light, 2 weeks of dark, which is what you got on the moon. You've got, gravity that's a bit more like Earth, 1/3 instead of 1/6. Mars it has an atmosphere which, as thin as it is thick enough to block out solar flares. So you could actually put thin-walled greenhouses on the Martian surface and grow plants in them and not have them killed by solar flares. You couldn't do that on the moon. So in all these ways, the Mars is a much more promising location for settlement than the moon. The analogy I use is Mars compares to the moon in the coming age of space settlement as North America compared to Greenland in the earlier European age of maritime exploration and settlement. Greenland's closer to Europe. Europeans reached it first. The Vikings reached it about 1,000 years ago. But it was just too impoverished an environment to really create a civilization. Some outposts, yes, but not a vibrant new civilization in the way that the Americas offered. So that's how it is. Mars is the new world.
The analogy that popped into my head when you were speaking is that the moon is like the trashy girl who's only good for a one-night stand, and Mars is like she has all the elements for a fulfilling, sustainable relationship. You just got to figure out a way, how to get in there.
Okay, well, that's another way of putting it.
But North America works too. That's just coming from my dirty, disgusting mind.
Okay.
So in terms of the plan to get there, you alluded to Musk's Starship plan that you've described as D-Day compared to your strategy, which is the Mars Direct plan. So I wanted to ask you first, how are your plans similar, you and Musk? What's similar about it? And then we'll get into the differences.
All right. Well, obviously, the Mars Direct plan came first. And it was a major break with the earlier paradigm, which is the von Braun paradigm. Okay, the von Braun paradigm, which is the first paradigm, is on-orbit assembly of huge interplanetary spaceships that go from Earth to Mars and back with all the propellant coming from Earth, park them in Mars orbit, send down little landing craft to go down, and usually for a comparatively brief stay, flags and footprints, go back up and fly the thing back. Okay, it's maximum cost, minimum capability. The Mars Direct plan involves the following elements: no on-orbit assembly, direct launch to Mars, direct return from Mars using propellant made on Mars. Von Braun does not use propellant made on Mars. That's why he needs all that other stuff. Okay, we do long-duration stays on Mars starting on the first mission. No on-orbit assembly, no advanced propulsion, but in situ resources, use of Martian resources starting on the first mission, long duration stays on Mars starting on the first mission. So that's the Mars Direct paradigm, and all that was embraced by Musk, including the particular propellant combination that I advocated, which is methane oxygen, as the easiest high performance propellant combination to make on Mars.
And so that would be for the return flight that you make.
Yes.
Okay.